displacement with metals. It's not always quite so easy. Sometimes we've got some oxygens involved. So when we have a oxygen in the ion, if we have any polyatomic ions with oxygen, we're going to have to take 2 more steps, really is all there is to it.
What's the number of oxygen atoms?
Of sounds good. Thank you, Carolyn. Bless you. Again, we're just going to add 2 steps to what we've been doing. If we have oxygen, it's different on each side. We're going to add water to whatever side we need more oxygens on. So I balance out my elements. Once I've balanced out my elements, I then balance out oxygen. But by adding water, I now have extra hydrogens that I probably don't have on the other side. So I'm going to add hydrogen ions, H pluses, however many I need to get that to balance out. So we're doing our normal thing. We're identifying what's oxidized, we're identifying what's reduced, we're breaking them into their 2 equations. From there, though we have to not only balance the elements that we normally have, we have to add water to get oxygens to balance and add hydrogen to get the water now to balance. And we can finish off with our charges. So looking at our first one, potassium manganate oxidizes a solution of iron ions to form iron 3 ions and also becomes Mn2+. So my oxidation part of the reaction is the iron. The iron's going from a 2+ to a 3+. There's only 1 of each iron, so I just looked at the charges and I see here that I have a 2+ charge on this side, a 3+ charge on this side, so I have to add 1 electron to my product side. Just good, because the oxidation part of the reaction should have electrons on that side. Okay, the manganate ion going to manganese is the reduction part. So the manganate ion is MnO41 negative, and that is forming Mn2+. But this is not balanced because we've got all of those oxygens. The manganeses are good. Got 1 of each on each side, so that part's taken care of. But now I need to add some waters. So if I need 4 oxygen, how many waters do I have to add to my product side? 4, thank you. So I'm going to add 4 waters because I need 4 oxygens. But I'm not done yet because now I have hydrogen on my product side. I don't have any hydrogens on my reactant side. So I'm going to have to add my hydrogen ions next. Hydrogen ions, does that mean I have a basic or acidic solution? Acidic, good. How many hydrogen atoms do I have to add to the reactant side? No. 8, yes. Because I deal with H pluses, not H2s, I need 8 of them because I have 4 times 2 here. I need 8 hydrogens added. So I have my MnO4, 1 negative, plus 8 hydrogen ions, 8 H pluses. So it goes to Mn2 plus 4 waters. Now I need to do, just like I did in the oxidation reaction, I need to figure out how to get the correct number of ions overall. Let's see. So we have one of the negative ones, and we have 8 positive ones. So on this side, I have a positive 7 charge. On this side, I have a 2 positive plus a 0, because water as a compound is just a 0. It's oxidation rule number 1. What side should I add electrons to? Yes. See the finger pointing that way, and I had to figure out what that way meant because I'm looking at it flipped on here. Sorry, yes, exactly. So I need to add some electrons to this side, which makes sense, right? Because it's reduction, so I need to add electrons to the reactant side. Show me with your hand how many electrons I have to add. Nice. Yeah, 5, absolutely. So I'm going to add 5 electrons to get the correct amount of charge on each side. I'm going to rewrite the 2 reactions here so that we can see them a little bit better because they were on 2 different slides. So this is just what we're dealing with. We have the oxidation half that we did at the very beginning. All we had to do to that one was add 1 electron. And then we have the reduction part, which took multiple steps because first we had to add water, then we had to add hydrogen ions, then we had to add our electron. What needs to be done now for me to be able to put them together? So now we're back to the regular steps we were doing yesterday. We deviated slightly, but now we're back on track. Go ahead. Yeah, absolutely. I need my electrons to be able to be canceled out, so my oxidation reaction needs to be 5. That's perfect. So now I have 5 Fe2 pluses going to 5 Fe3 pluses plus 5 electrons. That's absolutely correct. Now my electrons will be able to be canceled out. And now I'm going to have to rewrite it. It's going to be long. Why don't you start rewriting it on your own page? What's our final equation going to look like? So really we're just dealing with puzzles here. If you know the rules of the game, you'll win every time. We're just playing against chemistry. You can beat it. So we have 5 iron 2 plus ions plus the manganate ion, MnO4 1 negative, plus those 8 hydrogens that we had to add because we added the water on the other side, forming 5 iron 3 plus ions plus the manganese 2 plus ion and those 4 waters that we had to add because of the oxygen for the manganate ion. What questions do you have before I give you your final one to try? If you follow the rules,